Okay, so we're going to look at a couple more examples of simplifying with I using all of our operations. So we've kind of separately learned about adding, subtracting, multiplying, dividing. We had to use some complex conjugates to simplify the dividing. So what we're really going to look at in this video is what happens when we put all of this stuff together. Right? So if we needed to take something and divide and then add and then maybe multiply, what does that look like? So we're going to look at just two examples. Right? So in this case, it looks like I have a division problem. And then when I get the answer to my division problem, I need to add, right? So we're going to have to go through and do both of those things eventually, right? So when I'm looking at this, the first thing I see is that the bottom of the division problem is an issue, right? I can't have I in the denominator, and we talked about if you wanted to simplify with and get an I out of the bottom, we needed to multiply the top and the bottom by I in this monomial case when there's only one thing. So I'm going to kind of come off to the side here, and I'm going to change the way this fraction looks, and I'm going to say, well, if it was 3 plus I over negative 6I, what we said was if you want to get rid of the I in the denominator, multiply the top and the bottom by I. It's called rationalizing the denominator, right? And it looks like that's going to come out to be negative 6, and then I times I is I squared. So let's write that, negative 6I squared. And the numerator of this I applies to both the 3 and the I. So it's going to be 3I plus I squared. Okay? So let's simplify this a little bit more. Every time we see I squared, it's really negative 1. So this really says negative 1 times negative 6. Good, that's 6. No more I in the bottom. We fixed that problem. Okay. On the top, it looks like 3I plus I squared. But again, I squared is negative 1. So this is really saying negative 1 plus 3I. So I switched the order of these two things. This became negative 1. I put that first, and then the I goes second because we always try to set up our problems to be A plus BI. We always want the I to be second. That's called standard form. Okay. So I'm going to rewrite this expression. I just took this first part and I rationalized it, and I turned it into negative 1 plus 3I all over 6. And the second thing, the second part of the problem I didn't do anything with. So I'm going to say 3 minus 7I. Okay, so now the problem is I need to put these two things together, and I can't put together something that is a fraction with something that is a whole number. I can really just add together fractions and fractions, and even more specifically, I can only add together fractions that have common denominators, right? If I gave you a problem that looked like this, that was 1/6 plus 10, we couldn't add those together. I'd need to turn this into like 1/6 plus something over 6. So I need to turn 10 over 1. I'd have to go to this and say, okay, well, I need to multiply the bottom by 6 to get that, which means I need to multiply the top by 6 and turn it into 60 over 6. And now I can put these together. That's the exact same situation that we have here. I have a fraction over 6, and I have something that is not a fraction, right, like our 10 was. So I need to really say, you know what, I don't want it to look like this. I want the second fraction to be over 6 so that I can add it with the fraction that I already have, right? And so I'm really saying, well, okay, if this was over 1, okay, what I'm really doing is I'm going to this and I'm saying, let's multiply the bottom by 6. So I can get that denominator of 6, which means I also need to multiply the top by 6. So I'm going to take this 6 times the 3, that's 18, and the 6 times the negative 7 would be negative 42. Okay, so now, remember when I'm adding fractions, what I did over here is I would add the numerator, right, and get a 61, and I wouldn't change the denominator at all, 61 over 6. So I'm going to do the same thing. I'm going to say, don't change the denominator at all, it's over 6. Okay, but let's change the numerator. It's going to be negative 1 plus 18, right? When I'm adding complex numbers, I can add the real parts together. Negative 1 plus 18, well, that's 17. Okay, 3I plus negative 42I, that looks like negative 39I. Okay, this right here is my answer. The only other thing that you might have to look for is whether you can simplify, but since 17 is a prime number, I can't simplify that at all, right? So in this problem, I actually had to do rationalizing the denominator to get this. I had to go back and think about how I add with fractions, because that's what a division problem really is. A division problem is fractions, right? And then I needed to use my adding rules. So after I got common denominators, I need to use my adding rules to get the final answer. So we're putting together a bunch of these steps to get a completed answer, right? So here's the second problem. We're just going to take it up a notch. It's the same idea, but we're going to start them off as both being fractions, right? So the first thing I'm going to do is, again, I'm going to kind of come off to the side, and I'm going to rationalize each of these denominators. Okay, so I'm going to say in this case, the first one turns into 2 plus 5i over 1 minus I. Well, if I want to rationalize a binomial, right, a complex number in the bottom, I can't just multiply by I. Again, if you need to go back and look at the last video on how to do this, we're going to multiply by its complex conjugate, which is the plus version because I have a minus version here on the top and on the bottom. Okay, so the bottom is going to turn into, if I like FOIL all this out, 1, okay, plus I minus I, and then it's going to be minus I squared. Right? So again, you can go through and FOIL out these two binomials. This is what you get. Same thing on the top. I'm going to get 2. Okay, I'm going to get plus 2i plus 5i, okay, plus 5i squared. Okay, so again, what I did was I just FOILed out these two top pieces. Right? So now I need to simplify both of these parts. Well, if you take a look at the denominator, plus I and minus I, they kind of cancel each other out. They're gone. Okay, so this really says 1 minus I squared. Well, I squared is -1, so this really says 1 minus -1. 1 minus -1 is 2. Alright, that's the bottom. Let's do the same thing with the top. 2, okay, oh, well, let's put these together. That says 7i, right? 2i plus 5i is 7i, okay? And again, I need to look at this and I need to say, okay, 5i squared is really the same as 5 times -1. So this is really saying 2 minus 5, -3 is going to go in this spot. So my first fraction in its rationalized simplified form is -3 plus 7i over 2. Right? That's the first one. I have a plus sign, and I need to do that whole setup again, but with this fraction. So I'm going to say 3 minus 7i over 6 minus 2i. That is not rationalized, so I'm going to multiply the top and the bottom by 6 plus 2i, right, which is the complex conjugate. Here's what it comes out to be. I'm just going to simplify it. Right? It's the exact same procedure as this top problem, right? And it's going to look like 18, okay? And it's going to be, so I have minus 42 plus 6, which is minus 36i, and it's going to be minus 14i squared, okay? The bottom is going to look like, and again, I'll let you show, do all the middle steps to show the cancellation. It's going to look like 36 minus 4i squared. All right, so let's simplify one more time. -14 times the -1 is going to be positive 14. So this says 18 plus 14. 18 plus 14 is 32. Okay, minus 36i. The bottom is going to become, again, this is I squared is -1. So this really says -4 times -1, which is positive 4. This is all positive 4, so it's 36 plus 4, which is 40. Okay, I can simplify this a little bit more. If I'm looking at 32, 36, and 40, they all share a common factor, which it looks like is 4. So if I divide this by 4, I get an 8 minus 9i all over. When I divide this by 4, I get 10. Okay, so I'm going to turn this second fraction, I did all that work to turn this into 8 minus 9i over 10. All right, so now I have my simplified fractions. I did all that work. Let's do the last step. And I need to add together two fractions. If I'm going to add together two fractions, they need to have a common denominator. 2 and 10 are not common denominators, which means I need to go to this first one and say multiply the top and the bottom by 5. And I'm going to do that because 2 times 5 will make this one turn into a 10. Right? So I'm going to say the bottom of my fraction now is 10. The top of my fraction is going to be 5 times -3, which is -15. 5 times 7 is 35i. Right? So I changed the first one so that it has the same denominator as the second one. They both have over 10. Okay? So now I'm going to just simplify. Now that they have a common denominator, right, I'm going to add together the numerators. That's how we add together fractions. So I'm going to go to my problem and say this should be all over 10. Okay? -15 plus 8, well, that's -7. 35 plus -9 is going to be positive 26. Okay, I'm going to look and make sure there's no common denominator. 7 is prime, so I don't have to worry about that. Right, nothing is going to be in common. This is my final answer. Right, so this involved pretty much everything that we've talked about. You needed to rationalize denominators. Right, once we rationalized denominators, involved in rationalizing denominators, we had to multiply together complex numbers. We needed to find a common denominator, okay, and then we needed to add our two complex numbers together. So this has all of the operations in it. This would be like a summary of everything that we've learned about complex numbers. Right? Great problem to look at. If you understand this, you are good to go.